Hi everybody, welcome to our first lesson in Unit 12. Today we're going to be talking about simplifying radicals. A couple things before we get into that. The first thing is prime factorization means that we are looking for the prime numbers that multiply together to make another number. Prime numbers have only two factors, the number 1 and itself. So let's talk about some examples of prime numbers. Prime numbers are like 2, 3, 5, 7, 11, 13, 17, 19. And the list goes on. These are just the prime numbers under 20. And all of these numbers only have two factors, 1 and itself. So I want us to think about, how do we find the prime factorization of these numbers? I like to start by finding the prime factorization by dividing this number by one of these primes. And I always start with like the smaller one. So if I know this number is even, I'll always start dividing it by 2. If it's not even, I might start with a 3, a 5, a 7. But since this is even, I'm going to start with 2. So 2 times what gives us 40? If you need a calculator, use one. That's going to be 20, where 2 is a prime number. So I'm going to circle all the prime numbers kind of at each branch. So now I'm going to work with 20. What are some prime factors of 20? Well, it's even, so I know it's divisible by 2. 2 times 10 gets me 20. What about 10? What are some prime factors of 10? Well, I also know that's even, so 2. 2 times what gives me 10? 5. But 5 is also a prime number. So again, I'm circling all these prime numbers because again, I'm looking for the prime factorization. So how I would write the prime factorization of 40 is 2 times 2 times 2 times 5. All these prime numbers that I circled would multiply together to give us 40. Let's try 63 now. So I know that 63 is not even, so I'm not going to bother dividing it by 2. What if we divide it by 3? If we divide 63 by 3, we get 21. 3 is a prime number, 21 is not. What is 21 divisible by? Well, it's not even, so I'm not going to start with 2. What about 3? 3 times 7 gives us 21. 7 is here in my list of prime factors. So once I'm finished finding 2 prime factors in this branch, I'm done with the prime factorization tree. How I'm going to write that is 3 times 3 times 7. If I multiplied all these numbers together, I would get back to 63. So we're going to use prime factorization to simplify square roots. So I'm going to work on finding the prime factorization of each number under the radical. My goal is to find a pair of 2 of the same factor and move that number outside the radical. If there's more than one pair of the same factor, I'm going to deal with that by moving multiple numbers outside the radical. And if there's multiple numbers outside the radical, I'm going to multiply them together. Any factors that do not have a pair under the radical, a pair of factors, I'm going to leave it under the radical. So I know there's a lot of steps here, so let's start diving into what these steps actually mean. So for number 3, I'm going to start by finding the prime factorization of 4. I know it's even, so I'm going to divide it by 2. And 2 times 2 gives me 4. And both of these numbers are prime. So we're starting off with a very quick one. So under the radical, I could change 4 to 2 times 2. And a pair always means 2. So I have 2 2's. In order to simplify this radical, I'm going to move one number of the pair outside the radical. And then because there's no other numbers left here, there's going to be nothing under the radical. So the square root of 4 is 2. Now, we probably already knew that without going through all of this work. So again, I'm just kind of trying to go through the steps of showing you how we're going to simplify these radicals. So I'm going to start by finding the prime factorization of 18, because that's the number under the radical. So I know it's even. 2 times 9 gives me 18. 9 is not even, but I know it's divisible by 3. And 3 times 3 gives me 9. So I'm done with the prime factorization. This can be rewritten 2 times 3 times 3. I'm going to look for a pair of the same factor, and in order to simplify the radical, I'm going to bring one of those numbers to the front. So I'm going to pull a 3 out. All that, the whole pair is going to go away then inside the radical. Do you have any numbers left under the radical? Well, yes, I do. I have a 2. So then in the radical, 2 would stay there. And that's how we simplify the radical. Again, this is going to take a little practice for us to get used to this process. So we're going to do some more examples. So for number 5, we have the square root of 24. So we're going to start by finding the prime factorization of 24. 24 is even. So I'm going to divide it by 2. 2 times 12 gets me 24. 12 is divisible by 2. 6 is divisible by 2, and then 2 times 3 gets me 6. So the prime factorization of 24 would be 2 times 2 times 2 times 3. Find a pair of the same factor. A pair means 2, so I have 2 2's. Then I have no more pairs with this 2, and I have no pairs with the 3. So I'm going to bring the pair I found, I'm going to bring one of these 2's in front of the radical. The pair inside goes away, and then we have left a 2 times a 3 inside. Now, because the 2 and the 3 don't have any pairs, I'm just going to multiply these back together. So that's going to get me 6. So I want like a single number out in front of the radical, a single number inside the radical if necessary. Let's try another one. So we have 54. It's even, so I'm going to divide it by 2. 2 times 27 gets me 54. Well, 27 is not even, so I'm not going to divide it by 2, but I do know it's divisible by 3. 3 times 9 gets me 27, and I know 9's divisible by 3, and 3 times 3 gets me 9. So the prime factorization of 54 is 2 times 3 times 3 times 3. Find a pair of the same factor. Right here I have 2 3's. So that's the group I'm going to move out in front, but I'm only going to write one of the pair out in front. It's going to go away on the inside, and you're going to write what you have left under the radical. So I have a 2 and a 3 left. So 2 times the 3 I wrote down. Now, because I have no pairs with the 2 and no pairs with the 3, I can't bring anything out of the radical anymore. So all I'm going to do is multiply 2 by 3 under the radical, so I have one number in front and a single number inside. Let's try this again. Now, I know that I have a 4 out in front. We haven't seen that yet. But right now I'm not actually going to do anything with the 4. So I'm still going to start the same process by writing the prime factorization of 80. So I know 80 is even. So divide it by 2. 2 times 40 gets me 80. Well, 40 is also even. 2 times 20 gets me 40. 20 is also even. 2 times 10 gets me 20. And then 2 times 5 gives me 10. So the prime factorization, I'm going to keep the 4 out in front. So I have 1, 2, 3, 4 2's. 1, 2, 3, 4, and then I have a 5. I'm going to find pairs of the same factor under the radical. So I have a pair of 2's and another pair of 2's. The 5 does not have a pair. So I need to bring a 2 from this group out, but I also need to bring a 2 from this group out. So in front of the radical, I have a 4. From the first group of 2's, I need to bring a 2 out of the radical. So I'm going to cross that out and write a 2. And then from the second group of 2's, I need to bring another 2 out of the radical. Inside the radical, what do you have left? Just a 5. So again, if we're bringing more than one number out in front of the radical, we multiply them all together. So now I want you to clean this up and simplify. So what's 4 times 2? Well, that's 8. What's then 8 times 2? That's 16. So that's how we simplify that. Let's try another one like that. So again, I'm going to ignore this -2 for a second and just focus on figuring out the prime factorization of 63. 63 is not even, so I'm not going to divide it by 2, but I do know it's divisible by 3. 3 times 21 gets me 63. 21 has prime factors of 3 and 7. So I'm going to still write the -2, but under the radical, I'm going to write the prime factorization of 63, which is 3 times 3 times 7. Under the radical, I find a pair of the same factor. So I only have one pair, and that's one pair of 3's. I'm going to bring one of these 3's in front of the radical. I still, though, have a -2, so I have to bring one of these 3's out in front. They go away on the inside. What are you left with under the radical? 7. Last step is to clean up these two numbers and make them a single number. And in order to do that, we're going to multiply them together. So that's going to give me -6 times the square root of 7.